What's up, guys? Today we're going to talk about EEPROM data protection or write protection, how it works, and then we're going to present you with two different ways of disabling that write protection, either using a programmer such as this one or a DIY programmer based on an Arduino such as this one that I have built right over here. So first of all, a few days ago I actually ordered a few of these AT28C256 EEPROM chips. These are very popular. And out of the factory, they should actually come empty or just wiped and unlocked. However, the batch I got, and I read online, and a bunch of people seem to be getting batches like this, were not empty. They had some garbage data in there, and they were also locked. So when I tried to actually read and write to this chip using my DIY programmer that you see here, I was unable to. And I had to do a bunch of research to figure out what's actually going on and how to deal with that problem. So the first thing I did is I actually started debugging this DIY programmer a bunch. I thought that I had made a mistake somewhere and that's why it's not programming. I was actually able to read the contents of the chip, and that's how I figured out that it's not actually empty as it was supposed to be out of the factory. And it actually had some data, but when I tried to write to it, it was actually causing problems. So I spent a lot of time trying to figure out what my problem was. I thought it was a problem with the wiring or something like that. And it actually turned out that the problem is that the data was just write protected. Now, if you haven't actually seen one of these DIY EEPROM programmers, they're all over the internet. You can find a bunch of projects. I followed one by a guy named Ben Eater, and I'll actually post a link in the description if you guys want to create one of these. The reason you would choose something like this, or you would choose to use something like this compared to an actual programmer, is that these guys go for somewhere like 50-60 bucks. And then this thing uses an Arduino Nano, and it's actually very cheap. Like this whole thing probably costs around $10, I would say, maybe even less. And you might even have some of these parts lying around. There's just an Arduino Nano and a couple of shift registers, and this is just one of these EEPROM chips that I'm programming, and obviously a bunch of wires. So it's super easy to make. There's a lot of connections, but they're relatively easy to follow and figure out. And again, as I said, I'll link another video in the description where you can actually make this for yourself if you want to just have a DIY EEPROM programmer. However, even if you make that, or if you already made one and you have issues writing to an EEPROM chip, that's why I'm making this video, to tell you what the problem is and how you can actually kind of deal with it. This is kind of a weird video because I didn't actually create any of the tools that I'm going to talk about today. But I spent a lot of time researching how you can actually deal with the data protection, and I figured this video might help someone not have to go through all those steps and immediately just figure out what the solution is. So since the solution using an official programmer is super easy, I'll just leave that for the end. And I'll put some timestamps in the description below if you guys want to jump to the individual sections and you don't want to like follow along everything, if you're just interested into dealing with the official programmer, for example. But I'll start here because this is a bit more interesting, and also this is a more cost-effective way to program EEPROM chips, so might as well just deal with that first. All right, so as I said, my chips came programmed with some garbage data and locked, and I'll just put this one off to the side. And when I built this, it wasn't programming, it wasn't writing to the chip, it was just reading from it. And I'll actually show you why that is by switching here to this datasheet from this EEPROM chip. In the datasheet, you can actually see that there's a software data protection enable algorithm and disable algorithm. And these things I honestly didn't know that the EEPROM chips even had, but apparently there is some sort of a software data protection in there which can be enabled and disabled. And again, new chips from the factory should be with disabled data protection, but anyway, they weren't. Now, if you follow along these algorithms for enabling and disabling the protection, they're actually very simple. What you need to do is to load specific pieces of data into specific addresses on the EEPROM chips. So you start with loading AA to address 5555, then loading 55 to address 2AAA, and so on. So basically you have to load these values one after the other, exactly as shown here. And this will actually enable the data protection or make it kind of write protected. And then same thing goes with disabling it. Again, you load specific pieces of data at specific addresses in a sequence, as you see here. Now, this is actually fairly trivial to do, right? If you've done this project with the Arduino as a programmer, and you're trying to figure out how to enable or disable, well, okay, you can say that, yeah, just load some data into some addresses and that's it, right? The problem is right here. So this thing, it might look kind of crazy, but it shows us how we're actually supposed to load those load the data into those addresses, and there's a lot of timings to consider here. Now, I don't want to go into like extreme detail at this point, but the important thing to note out of this whole thing is that the timings in which you send these, in which you send the data to these addresses has to be very precisely controlled and is in the order of nanoseconds. So basically, you have to send the data to these addresses very quickly, one after the other, right? The 5555 and then the 2AAA. These addresses have to be written to very, very quickly. And that's kind of the first problem that you will encounter if you use something like a DIY programmer based on an Arduino, which is what I was using. Because the Arduino isn't actually accessing the chip that fast, and it's not writing to it that fast. And even the delay that you can actually issue as a command in an Arduino is a delay microseconds, right? So you can delay for 1 microsecond, for example, but that's too, even though it's only 1 microsecond, that's still too long when you're talking about delays in nanoseconds, as you see here. So we need a way to get around that restriction and to actually send the data faster. So that's kind of what I started researching next. I was thinking, okay, so how do I actually, or is it even possible to write data faster? And that led me to this page. And this is from the Arduino documentation. I'll put links to all of these things in the description so that you guys can follow along if you want to. But basically in here, it talks about something called port registers. And basically what port registers are, is it's a way to read and write to the ATmega chip, which is kind of the brains of the Arduino platform, or the microcontroller on the Arduino platform. It allows you to read and write to these port registers much faster than when you're using a digital read or a digital write. And that's because using the digital read or write functions in the Arduino API actually does a bunch of stuff under the hood, and it kind of slows down the whole process. So in this case, by using these port registers, we're actually directly accessing the ATmega chips that are on the Arduino and are able to perform the read or write operations much faster. Now, the problem with this is that these port registers depend on the actual microcontroller that's on the Arduino. So like in the case here, for example, we're talking about ATmega 8 and ATmega 168. So depending on the Arduino you have, you may or may not be able to use this, or these port registers might have different assignments than what's in here. So for example, depending on whether you're using an Arduino Nano or Arduino Uno or Arduino Mega, you may or may not be able to do this. And also, compared to a digital read and write, these port registers in controlling them and writing data to them, it's a bit more complicated, it's a bit more involved. It involves kind of a bit mask where each bit represents a register, and then it represents whether you're writing to it or reading from it and stuff like that. And I'll put this in the description. You can kind of go over this page if you're interested in doing something like this. And it goes into detail on how to actually perform those reads and writes and some examples. Like over here, for example, you can see these bits being set in a specific pattern, and each bit over here represents something different, and it tells us whether we're reading from something or writing to something, etc., etc. And that's why you wouldn't use something like this. Also, using a digital read or digital write, it's kind of an obstruction on top of this. So those functions actually handle these things for you. So regardless of which Arduino you're using, the code that you write that contains digital read or digital write will be the same code. So you don't have to worry about working on one Arduino platform or the other and porting the code and stuff like that. And then obviously the good thing about using this, and this is in here somewhere in the pros and cons, the good thing is that it's much faster. So compared to a digital write, for example, using these port registers allows you to write much faster, and that's exactly what we need to actually deal with this problem over here, right? Because we want to set the data in these addresses very quickly. So I started writing a code for myself to actually deal with this. And while I was researching and kind of trying to figure out, okay, how do you use these port registers and stuff, I actually came up with this GitHub page. And I should note that I'm in no way involved in the creation of the tool that's in here and the software. This is all made by a guy named Tom. So shout out to him. He already made exactly what we need. He made an Arduino based EEPROM programmer. So it's similar to the one I have over here. It might even be the same. I'm not actually sure. Just looking at it here, it looks like it has. Actually, I'm not showing you. Looking at it here, it looks like it has an Arduino Nano again and a couple of potentially shift registers. I mean, that's kind of what this is. I don't think it's something different, although I haven't made it for myself. But the cool thing about what he's done over here is that he's actually taking advantage of these port registers to do very fast reads and writes. And if you kind of go over his documentation here, I don't know if I can find it right now, but basically what he's done is when you boot up his application, it allows you to specify what you're actually trying to do. So, for example, if you're trying to write data, you would push, I don't know the exact commands, you'll have to read through the documentation, but let's say you push W to write data, R to read data, or something like that. And he even has commands to actually disable and enable the protection on the EEPROM chips. And that's the cool thing about his project, is that he's actually already dealt with what I was going to do in the first place and deal with these port registers. So I'm not going to go over the procedure, and that's why I said this video is kind of weird. I'm not actually going to go to the procedure of setting all of this up, because it's literally just you follow along here, you make your own DIY programmer, and then you install his libraries. In here, he includes a bunch of Arduino code as well as some C code and some header files. There's a couple of things that you need to actually import. But after you load in his application in your Arduino, you'll be able to program it, and you'll be able to actually disable the protection, which is pretty cool. And again, I'll put links in the description below for you guys to actually find this GitHub page and use his project. If you want to, if you're stuck like I was with not being able to write to your chip. Now, something interesting that I found out while doing my research is that depending on the type of chip you have, like in my case, I have the AT28C256 by ATmega. It appears that this particular EEPROM chip, let me actually switch. So this particular EEPROM chip is a little bit more strict when it comes to these timings for locking and unlocking it. From what I've read, some people have actually succeeded using a digital read and digital write, so just the normal Arduino write commands, to actually change the data protection on their EEPROM chips, which were different. So depending on the EEPROM chips you're dealing with, you could actually try, just going in here and sending this data to these addresses in a sequence, one after the other, to flip between a locked and unlocked state. That may work for you. That's kind of the best case scenario, because you don't need to do anything fancy really. You just need to code this data, and you can probably find whatever the kind of the sequences for your chip by just looking at the data sheet for your chip, the chip you're using, obviously. Now, if that doesn't work for you, then I would suggest checking out that GitHub page and following the project over there, and then kind of dealing with it that way by using the low-level port register read and writes. Okay, so now that we've dealt with this, and I actually haven't tried it using that GitHub page, but I read a bunch of people that did and had success with it, so I'm kind of promoting it. I think it's doing what it's supposed to be doing. I just kind of looked at the code, and it sort of made sense, if that makes sense. So in my case, I was able to unlock my chip by using the programmer, and then I put it back in here into my DIY project, and everything worked fine, so I kind of know that works. So okay, so let's talk about how you can actually use an official programmer. I'm just gonna leave this off to the side here. So let's talk about how you can use something like this to actually read and write and lock and unlock your chips. Now, the programmer I have here is the TL866II Plus. And this is a very common EEPROM programmer. It's used kind of widely, just judging by my online research. It does a bunch of cool things. It has adapters for all sorts of EEPROM chips and stuff like that. The downside is, as I said before, it costs about 50 or 60 bucks. So if you're looking to get something, on the cheap, then I would suggest checking out that GitHub page, doing something like this, which will probably cost you around $10, and you're kind of done. But in this case, let me show you what happens with this programmer and how to deal with a locked unlocked state. So you have to actually line up this. I don't know if you can see it on camera, but this little notch over here, you have to line it up this way. I'm gonna put in the programmer and lock it. All right, so I'm just gonna switch now to the software that comes with this programmer. I have it over here. All right, so if we just do a read on this chip right now, you'll see the data over here just shows all Fs. And what this means essentially is that the chip has been cleared out. So that's what happens when you wipe these chips. They're just all Fs. If I try to, let's say, program something on it, and I'll just open up, let's see, I wrote a test binary earlier. So just load that in, and you can see I just made changes to this first few address lines, and I just wrote 0, 1, 2, 3, 4, just so we can see something happening, right? FFF is just everything is erased, and this is not on the chip right now. This is basically something that I have kind of in computer memory, and I'm about to write it to the chip. So here's what I want to point out. I want to point out these two settings right here. You see where my cursor is. It says off protect before programming and protect after programming. Obviously, this is not really a great translation into English, but this is exactly what you need. Now, these two checks, basically what they mean, the first one is disable the protection before programming. And the second one is enable the protection after programming. So by default, these are both checked. And what's going to happen is when you try to program something, it's actually going to unlock it. So it's going to send that sequence of commands. It's going to unlock your chip. Then it's going to program whatever you have here, and then it's going to lock it again. So let's actually uncheck this first option. So I'm not going to disable the protection, and I'm just going to try to write to it directly. So I'm going to try to program this, and it's going to start doing things. And it's going to spit out an error code. Now, what this means is that, obviously something went wrong. And at this point, I actually know what went wrong. It tried to program to the chip without actually having the chip unlocked, which is the problem I was facing with my custom programmer as well. If I try to read the chip again now, see, this changed back to all Fs again. And basically what this tells me is that the thing that we were trying to program to it did not work. So it's still blank, it's still empty. So I'm just gonna load that test binary again, and again in memory, not on the chip itself. And I'm gonna tick this box again now. So I'm gonna unlock it, and then I'm gonna lock it afterwards. So if I actually, let's do this. I'm gonna untick the second box now. So I'm not going to lock it afterwards. So let's see what happens now. So now I'm gonna go and I'm gonna try to program to it, and it's gonna do its thing. And there we go. It actually didn't spit out any errors this time. It says programming successful. It seems that everything is fine. So if I try reading it now, it says that the read has finished. And actually, if you look over here, I still have those 0, 1, 2, 3. I still have those fields that I set. So I managed to actually unlock the chip. And because I didn't actually tick this box, what I can do now is I can actually untick this box too. And again, I can load that test binary. At this point, actually, let me erase the chip first, so that we're starting with the clean slate and we can actually see the change. So you can see again, everything went to FFF, so the chip is blank. So now I have both of these unchecked. So I'm not gonna disable protection before programming, and I'm not gonna enable it after programming. So if I load my test binary one more time, and I try to write it. Now, remember, the last time we did this, I had this second checkbox unchecked, so I wasn't re-enabling the protection. So if I program now, by default, I have it selected to erase the chip before it programs it. It doesn't really matter. But see, everything went successful. So, and if I try to do a read again, the read finished, and I can actually see that it's not blank, so I managed to write to it. So just something I wanted to point out, because these are not well documented. Even if you look at the help file, it actually doesn't really talk about these two checkboxes, these two properties here, even though they're extremely important. And basically what I wanted to mention is that if you have maybe a friend or relative or someone that actually has a programmer such as this one, they can actually erase these chips for you. So even if you're having trouble using a DIY programmer such as this one, and you can't really figure out the thing I was talking about before, you can't figure out Tom's project that actually can disable the protection for you, you can perhaps find someone that has a programmer, send them your chips, have them unlock them, and then send them back to you. Because once they're unlocked, unless you manually have the code that actually resets the protection back, they're gonna remain unlocked. So at that point, you don't even have to worry about any of this, because everything is just gonna work. So that's pretty much it, guys. Those are the things that I kind of wanted to mention this time. Again, I didn't really write any of the software or code or tools or anything like that, but I did get stuck for a little while, and I had to do the research. So hopefully this helps someone go through the process a bit smoother than I did, and then potentially you can write something for yourself and write something in the Arduino that actually does the locking and unlocking for you. In any case, that'll be it for this video. If you like the content I have on this channel, consider subscribing, liking, all that good stuff, and I'll see you in the next one. Until next time, bye.